just a moment ago, we were typing in the standard form of an equation, the factored form of an equation, and the vertex form of an equation. So we're going to flip over to Desmos and we can look at these different equations. I have them typed in ahead of time. The first one being the y equals the x squared plus 6x minus 7. So I'm going to turn that on. And here's the picture of our graph of the standard form of the equation. And the factored form of the equation is our next screen. And if I turn that one on, notice that the blue equation landed right on top of the red equation, or I should have said better, the blue graph landed right on top of the red. And then our vertex form was this one, and if you work ahead of me, what you're going to see over here in Desmos is that it's a green graph now, but we only have one picture. So I'm going to turn the video off for a minute to ask questions about what do you notice, and then I will turn it back on once we've got the class notes put in there. So if you're watching this video at home, you see the answer to what do you notice. We ended up, when we typed all three of those equations into Desmos, we came up with the same graph. And then a good question came up, which is there a way to go from one form of the equation to another? And that's kind of going to be answered throughout our unit here, but the answer is yes. But let's stick with our equation here. We have it in Desmos, or we have it on our graphing calculator, or we have it on our phone. And the nice thing about Desmos is that we can go back to Desmos and we can touch the graph. And then we get some points that show up on this graph. So try this again. But what I see right here is a vertex, and I tapped it, and we see -3, -16. That's going to be a point that we're going to graph on this part 2 here as we get ready to fill out our key features. So if you want to work ahead of me, -3, 16 is one of the points that we're going to have on here. As well as we see some other gray points here. There's a gray point here at 1, 0. And there's a gray point there at -7, 0. So we've got the vertex. We have this point here of 0, -7. And let's graph all of those points on our paper here in front of us. -3, -16, as well as 1, 0, and -7, 0, as well as 0, -7. So there's the points that we have. One of my notes that I made down here at the bottom, any other thoughts, noticing patterns or notes, is I found a point that corresponds with our y-intercept, and that is the point -6, 7, -7. It is another point on the graph. I'm going to put that in there just to make a little bit better of a picture. But -6, -7 here. And do the best that you can to draw the picture. Because once we have a good picture, then we can answer the questions off to the left here. So let me give you a moment to get that drawn in there if you haven't already. So if we look at a picture, the y-intercept. Well, the y-intercept is right here. And it is 0, -7. Where the graph crosses the y-axis. Zeros, roots, x-intercepts, and that's what zeros and roots are, is they are x-intercepts, are these 2 points right here. If you did use Desmos, what you saw is you saw 1, 0 when we clicked on that point, as well as -7, 0. They're called zeros of the function because the y value of an x-intercept is always 0. I tend to use the roots or x-intercepts more. There's something called the axis of symmetry. It is a line that goes right down the middle of the graph, cutting the graph in half, such that if we fold our graph along the line, the right side of the graph lands on the left side of the graph. And the thing about the axis of symmetry is that it always goes to the vertex. So I'm going to start here at the bottom and start drawing in. I usually draw a dotted line for the axis of symmetry. And again, now that you can see the axis of symmetry, what happens is it's a line that cuts the graph in half, such that the right side of the graph will land directly on the left side of the graph when we fold that graph along the line. I'm super picky about the format of the axis of symmetry because it is a line, and this is going to be x equals. There's the line part of it. Well, where it crosses the x-axis is, I'm going to put a little dot right there so you can see what I'm talking about, is at 1, 2, -3. It goes through the x value of the vertex, which is our next item on our list here. The vertex, I'm going to put it in a better color here. I'll put in black. Down here, at the very bottom of our graph. Again, if you were using Desmos and you clicked on that, it gave us the point right away, which is -3, -16. Our next value says, is the turning point. Well, notice that I did call that point, -3, -16, the vertex. It's also called a vertex. It goes back to some old knowledge that we have, which is when we read a graph, we read it coming from the left. So as we come from the left, what happens is we start going down, 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 down. We get down here to the black point, and what happens at the black point is we change direction and we start going up, 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 up. We turn, we change direction. That's why the vertex is also called a turning point. But what we're looking at when we're looking at the vertex or the turning point on our next item in our list here is this point a low point or a high point in the graph? And as you can see from the picture, it is a low point on the graph. So this is going to be called a minimum. Finally, the last two items in our list are the domain and the range. We haven't dealt with them for a while, but the domain of a quadratic function is all real numbers, -infinity to infinity. Remember that infinity always has parentheses when we write in interval notation. The range, however, is not infinity to infinity, negative infinity to infinity. And what we ask ourselves with regard to the range, which range represents the y values in the graph, is do we have a high point? Do we have a low point? Well, we have a low point, and our lowest y value in this graph is negative 16. And then what happens is the graph goes up. Every point after negative 16 is higher than negative 16. So we go up, 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 up. This graph continues on to infinity. And again, infinity always has a parentheses, but this is going to have a bracket. Negative 16 is a point on the graph, but we can't define infinity. So flipping our page. I ran out of space here. I tried to fit this on front and back sides of paper, but I put the 3 types of equations at the top of the page on my screen, even though they're not at the top of the page on your screen. But as we take a look at this here, it says which form gives you the y-intercept in the equation. And that hasn't been really clear so far in what we've been doing. But let's answer the question anyway. It's going to be the standard form. We'll provide the y-intercept. So that's going to be to the far left, standard form. The way we find the standard form is it's the ordered pair 0C. If you recall, in this equation, A is 1, B is 6, and C is negative 7. So the y-intercept, as we notice on the front of the page, was 0, negative 7. That's one of the points that we had to graph. Which form gives you the x-intercepts or the roots in the equation? Well, we've been doing some of this throughout this year, and it is the factored form. If we look at that middle equation, if you remember, what's happening is we would take x plus 7, one of our factors, and set it equal to 0. And we would also take x minus 1 and set it equal to 0. And we're going to have to subtract 7 for both sides. So we get x equals negative 7. And we would add 1 to both sides. We would get x equals 1. And if you recall, the way that we wrote the roots on the front of our paper was we wrote negative 7, 0, and we wrote 1, 0. So there's our 2 ordered pairs there. So if you follow my logic, you can probably guess what the third value is on here. And I'm going to let one of my students who's dying to be on the video say it.
Vertex form.
Vertex form. It's the vertex form on this one. And where we can find the vertex on this one is if we look inside the parentheses, or if you remember from the front, it was negative 3, negative 16 was the vertex. And what happens in this format is we look inside the parentheses and we change the sign on that. So since it was plus 3, we rewrote it as minus 3. And then for the negative 16, we keep it negative 16. So I often say, change the sign, keep the sign when it comes to the vertex. So lastly here, when we fill in our last chart, is which form do you think gives us the most important information needed to sketch an accurate graph? I actually answered it with 2 values. I think that the vertex form is really important. I think knowing what the vertex is that gives us the turning point of the graph. But not only that, but then the factored form also gives us the roots, and that allows us to get a shape of the graph. If you're writing down, I didn't do a very good job with functional English, but we will be able to get the proper shape, which is a graph of a quadratic is a U-shaped curve. And that's what the vertex will give us the turning point, and then our intercepts, our x-intercepts, will give us enough to be able to draw the picture. So let's take a look at an example here. It says, using the following equations, sketch a graph and label all the key features listed. Well, we don't know everything. Eventually what we're going to have to do is we're going to have to type this into our graphing calculator or into Desmos. But we can come up with a couple of pieces in this graph, or at least one on this one, and actually two pieces on this graph. The first piece from our format, which is the standard form of the equation, allows us to find our y-intercept, and our y-intercept is going to be 0c. So when we look over here, A is 1, B is -4, and C is 3. So our y-intercept then is 0, 3. And we can graph that. Over 0, 1, 2, 3. There's our y-intercept. The other part that we really can find is we can find the roots of this. But what has to happen is, in order to find the roots, we need to have the factored form. So if we take this equation, and maybe you want to write down here, which key features of the graph do you think are easy to find using the equation? Maybe in this box, you write down the factoring. X squared minus 4x plus 3. Remember, to factor this equation, we're going to split the middle. So 1 times 3 is 3. And those are our only factors. We need to combine to be -4, which is going to be -1 and -3. So this becomes x squared minus 1x minus 3x plus 3 when we split the middle. And then we can group. Here's a group. Here's a group. So our greatest common factor is x, and then we're left with x minus 1. Our greatest factor in the second group is 3, and we're left with x minus 1. And then what we have in the factored version here is we have x minus 1 times x minus 3. But what we're really looking for on this problem is we're really looking for the roots. And the roots are the x-intercepts of this function. So either down still in the box, which you might be running out of space, but we can take the x minus, not in that spot, but take the x minus 1 and set it equal to 0, as well as taking the x minus 3 and set it equal to 0, and because I'm running out of space, x equals 1 and x equals 3. So those are the other pieces that we can put into our picture here. X equals 1 and x equals 3. And again, we need to know a little bit more before we can get this entire picture graphed. So I'm going to flip over to Desmos and look at the picture. And flipping over, I'll turn this one off. Turn it off. Third time's a charm. Turn that off. Oh my gosh. And off. And off. And the graph that we were just looking at is the x squared minus 4x plus 3. Turn that one back on. And slide this down a little bit. What we really need here is we need the vertex. And the nice thing about Desmos is you can touch the graph and come up with the vertex, which is the 2, -1. We already have the y-intercept. We just found these 2 points here, so we have those as well. So we have pretty much enough to graph, but again with Desmos, the nice thing is we can touch the graph and we can come up with this point as well, which I can't keep up there, but it looks like it's 1, 2, 3, 4, 3. And we can go back and we can fill those in to our paper. So once again, the vertex is here. And then the other point was 4, 3. So now we have a good picture. And we also can fill in our vertex over here in our chart. Vertex being 2, -1. Reminder that the axis of symmetry is the line that goes right down the middle of the graph, and it goes through the vertex. It only touches the graph once, and that's at the vertex. The axis of symmetry again splits the graph in half so that when we fold the graph, the right side of the graph lands on the left side of the graph. And it's an equation. It's x equals 2. And as we take a last look here at this particular picture, what we've got is we've got a low point on the graph. So our low point is also called a minimum. Last example here. Y equals x plus 2 quantity squared minus 1. This particular equation is in vertex form. So we can find the vertex of this particular problem. Our vertex being change the sign. So we're going to change the sign on 2, so it's going to be -2. And then we're going to keep the sign. We're going to keep the sign on the -1. So our vertex is -2, -1. And we can graph that point over there on our graph. Not only can we find the vertex in this particular problem, but once we know the vertex, we can find the axis of symmetry. Because remember that the axis of symmetry only touches the graph in one place, and that's at the vertex. So if we draw the axis of symmetry here, what we end up with is we end up with x equals -2. Again, most Algebra 2 teachers are picky. The axis of symmetry is a line, so it needs to be written as a line. X equals -2 represents a vertical line. Now the rest, we haven't learned how to find yet, but by the way, before I flip over to Desmos, which key features of the graph are easy to find? It's going to be the vertex and the axis of symmetry, and I'm going to abbreviate axis of symmetry as A for axis, O of S, symmetry. Those are the two pieces that we can find. But for the rest, we haven't learned how to do it yet. So we're going to flip over to Desmos momentarily, and we're going to type in the equation so that we can get the rest of the points on our graph and answer our questions here. Turn this one off. Turn this one on. So here's our picture. Again, the advantage of Desmos that's not true for the graphing calculator is that we can touch this graph and we get some great points. Now we already know this point. We already found our vertex. But what we can see here is we can see this point and this point. We can see our x-intercepts, also known as our roots or our zeros of the function. And we can finally see our y-intercept of this graph. So now we have a couple of points that we can use as we flip back over to our paper to write these on. So once again, what we saw on Desmos is we saw this value right here, negative 1, 0. We saw this value, negative 3, 0. So we can fill those in. Negative 1, 0, negative 3, 0. We also saw our y-intercept, which was here. And that ordered pair is 0, 3. And let me just point out again, the axis of symmetry cuts the graph in half. So as we take a look at this point here, the y-intercept is 1, 2 spaces away from that pinkish purple line. So 1, 2 spaces away on the other side of that pinkish purple line gives us another point. Now we could have found that on Desmos, but I just want to show you that we could also do that by hand. We're going to do the best we can to draw our picture here. Looks like that. And the only other piece to identify is, are we working with a maximum or are we working with a minimum? And once again, the lowest value on the graph is our turning point, also known as our vertex, which means that we are working with a minimum.